Hi, this video will provide another example of solving systems of two equations and two unknowns. Again, this video will talk about using substitution. Now, while I look at this, my initial thought is to try to find the variable that is easiest to isolate. So you may be thinking this probably isn't the best category for substitution in that one of my variables is not going to be very easy to isolate. But on second glance, it does appear that I could probably isolate my y in the first equation. So let's try to do that. So I have 4x minus 2y equals 16. To isolate y, I'll subtract the 4x each side. Okay, so I'm left with minus 2y equals minus 4x plus 16. And now I need to get rid of the negative 2, so I'm going to divide every term by negative 2. Now this one works out okay because every term was an even number, so I know when I divide by the negative 2, I'm not going to be left with any fractions. Negative 4 over negative 2 yields a positive 2, and I have my x. And 16 over negative 2 gives me negative 8. Okay, so now I have been able to isolate my y. And this is the substitution method. So I'm going to take this and plug it into my other equation wherever I have a y. So I'm going to plug it in right here. Rewriting that second equation, after I substitute, I get 5x plus 7, and now in place of y, I'm sticking that whole thing, 2x minus 8 equals 1. Now I'm ready to solve this for x. The first step I need to do is to distribute my 7. Okay, 5x plus 14x minus 56 equals 1. 5x and 14x yield a 19x minus 56 equals 1. Add 56 each side. I get 19x equals 57. Divide each side by 19. I get that x equals 3. But I am not done with this problem, because while I know what x is, I still don't know what y is. The easiest thing to do is to plug x into the equation where you've already isolated y and determine what y is. So y is going to equal 2, and now I have an x there, but I'm going to plug in my x value from over here, times 3 minus 8. I get that y equals 6 minus 8, or y equals negative 2. So if I want to write my solution as a point, I get 3, negative 2. Once again, this was the substitution method. It wasn't very apparent that we could actually use it at our first glance, but if we look at the first equation, we see that all our coefficients are even and that the coefficient in front of y is a 2. So that was our indication that we could probably isolate y without having to deal with those pesky fractions. Once we isolate one of our variables, we substitute into the second equation, solve for one of our variables, and once we get that variable, we substitute back in to get the other. I hope this helps.